And finally, section 1.3, part 3. We have 2 more examples to work through. So example 5 says, throws a lot of information at you in example 5. At a unit price of $55, the quantity demanded of a certain commodity is 1,000 units. At a unit price of $85, the demand drops to 600 units. Given that it's a linear function, find the demand equation. And then it asks a couple of other questions, but let's tackle with that part of it first. So they are throwing information at me. They're talking about the unit price and the quantity demanded. Well, anytime you have a supply or demand, either one of them. So supply, which is the next example, or demand, which is our example. What we're going to notice in terms of the XY plane is that the input value is always the number of units you're being produced or being sold. The Y, or the vertical axis, is always going to be your price. And that's important so that you get the points written in the correct order in order to be able to do the slope correctly. So at a unit price of $55, the demand is 1,000 units. So they're telling me that I've got 1,000 units and it's $55. At a unit price of $85, so now that's the Y value of 85, the demand drops to 600 units. So they've given me 2 points. We know what to do to write an equation here. So let's come in and find that slope first. So again, the first step, find M. So step 1, find M. So M is going to be equal to Y2 of 85 minus Y1 of 55 all over X2 of 600 minus X1 of 1,000. So 85 minus 55 is 30, and 600 minus 1,000 is a negative 400. So I'm going to reduce that into a negative 3 over 40. And I tend to not use decimals, but because it's an application problem, let's go ahead and take that to a decimal. If you take that to a decimal, it comes out to be a negative 0.075. So what this is telling me over here in this form is if you drop the price by $3, you're increasing the number of units demanded by 40. So which makes sense. If you lower the price, make it cheaper, then more people want it. So that does make sense. This time they didn't give us the y-intercept. So we're going to go to the point slope form to write the equation of the line. So we're going to backtrack to that y minus y1 equals m times x minus x1. You can use either point. I'll just use the first one I pick up. So y minus 55 is equal to negative 0.075. And then we'll have x minus 1,000. You do need to clean this up and write this into y slope intercept form, y equal mx plus b. So we'll distribute our 0.075 negative. So y minus 55 is equal to a negative 0.075x. The negative times the negative is going to make that a positive, and 0.075 times 1,000 is 75. Then all we need to do is move over the 55, and we'll end up with y equal a negative 0.075x. 55 and 75 are going to add to give me 130. Just so you know, in general, demand equations have a negative slope, so this thing is going down. That's a demand equation. So, which makes sense, again, the lower the price, the more the demand. So we found the equation. They want to know above what price will there be no demand. So in other words, if we make it so expensive that nobody wants it, they're asking for the y-intercept. So what we're going to do is come in and let x equal 0. So the y-intercept, let's let x equal 0. So that would be y equals 1,000 because x is 0 now. I'm sorry. I have no idea where that came from. Y equals 130. So if our unit price is $130, nobody's going to want to buy our product because it's too expensive for what you're getting. It then goes on to ask you what quantity would be demanded if the commodity were free. So if we plug in, well, that's the same. No, if we plug in y equal to 0, so it's free. So 0 equals the negative 0.075x plus 130 and solve that. And negative 130 equals a negative 0.075x. Dividing out the 0.075 gives us 130. So if we sell 130, there'll be a demand of 130 units if the unit price is 0. I'm going to check that because that doesn't sound right to me. Hang on. I don't think that is right. 130 divided by 0.075 is 1733. Yeah, that didn't make sense. Notice that logically it made no sense. So I double checked it because our numbers up here in terms of units are 600 and 1,000. So it didn't make any sense. This thing is doing this. We're out here somewhere. Where are we? So X is equal to 1,733.3 units. So if you make it free, the demand for that product will be 1,733. And that's the demand equation. Let's take a look at a supply equation. So our last example for this section, example 6, tells us that suppliers of a certain brand of digital voice recorder will make 10,000 available in the market if the unit price is 45. So again, the number of units and the price. At a unit price of $50, 20,000 units will be available. Assuming the relationship between the price and the quantity supplied is linear, derive the supply equation. And then, of course, it asks some questions about that, but let's try that supply equation first. Same steps we did last time, we need the slope. So M is equal to, we'll do 50 minus 45 all over 20,000 minus 10,000. So that's going to give me 5 over 10,000. Notice it's a positive slope this time. Supply equations in general have positive slopes. So demands are negative, supplies are positive. That's actually, if we divide it out, going to give us what, 0.0005. Make sure I have the right number of zeros on that. They did not give us the y-intercept, so we need to go through the point slope form in order to write the equation. So we'll do y minus the 45 is equal to 0.0005 times x minus the 10,000. So y minus 45 equals 0.0005x minus 5 times that 10,000, I think is just going to give us 5. Then all we have to do is move our 45 over. Y is equal to 0.0005x plus 40. And again, remember that x is the number of units, y is the price. So units and price. So the second part, we now have our equation. The second part of this problem says, sketch the supply curve and determine the quantity suppliers will make available when the unit price is 70. So they're telling me that the unit price, y, is 70. We need to find x. So we're going to let 70 equal the 0.0005x plus 40. So if I move the 40, I'll get 30 is equal to 0.0005x. And then all we have to do is divide. So it looks like if you divide that out, you get 60,000 units. Okay, which should make some sense if we're thinking about what we're doing. We know that we have a point at 45, 10,000. We know by 50, we're up at 20,000. So by 70, we should be way up there. So it looks something like that. And that wraps up our linear functions. In our next section, we're going to take a look at finding points where supply and demand cross or equilibrium points.